Question 6. Consider the binomial expansion x plus 1 to the power of 7 equals x to the power of 7 plus ax to the power of 6 plus bx to the power of 5 plus 35x to the power of 4 plus ... plus 1, where x can't equal 0 and a and b are part of positive integers. And part A asks, show that b is equal to 21. All right, cool. So let's look at what we need here. So obviously we're going to show that b is equal to 21. And we can see from our expansion that b is the coefficient of our x to the power of 5 term. All right, so we're going to need to go to our formula booklet and use the formulas that we have for the binomial theorem, which is over here, and we can see down here. So let's just copy what we've got there, and we'll bring these over. Nice. Okay, cool. And so the main thing that you're going to want to sort of pay attention to here is the general term here. All right, so this idea. So NCR is equal to a to the power of n minus r multiplied by b to the power of r. All right, and then our circumstance here, x is a and 1 is b. Okay, so if we apply that idea to bx to the power of 5, all right, we can sort of say, well, n is going to be equal to 7, a is equal to x, and b is equal to 1. And we got to do a bit of thinking to find out what r is, but unfortunately it's not too tricky. So if we're trying to find the x to the power of 5 term, x to the power of 5 term, which is, funnily enough, equal to b, all right, which is going to equal n, so NCR, and n is 7, all right, we'll put r down here for now, 7CR multiplied by x to the power of 7 minus r, and multiplied by 1 to the power of r, okay? And so now we got to think, what sort of value of r do we need to make the power of x equal to 5, right? And when we sort of go through this, we can sort of conclude that it's going to be 2, all right? Because 7 minus 2 is equal to 5, right? So therefore, r is equal to 2, and we can sort of bring our working down. Let's grab this, bring it down. Let's change r's to 2, and then another 2. All right, cool. And so we know that 1 to the power of anything is just going to stay as 1. We know that this has now become x to the power of 5, so that's happy. So we can conclude that b is going to equal 7c2. And actually, to be technically correct here, how about we put in bx to the power of 5? We'll go back it up a little bit. We'll put bx to the power of 5, x to the power of 5, and we'll include that down here as well. I don't think you'd necessarily be marked wrong if you didn't put this in, but that's just to help with understanding, okay? So then we can go over here. So therefore, b is going to equal 7c2. All right, cool. There we go. And we can even cancel out these two terms, and 1 to the power of anything is just going to be 1. All right, cool. So now we've got b is equal to 7c2, and so now we're going to have to move on to the NCR formula, or this formula down here, where we have n factorial divided by r factorial multiplied by n minus r factorial. Okay, so if we apply this, so then we can come down here and we'll say b is going to be equal to 7 factorial over 2 factorial multiplied by 7 minus 2 factorial. All right, so there's a few things we can kind of do to make our life a little bit easier here. So if you're not familiar with what factorial meant, so 7 factorial, for example, is 7 times 6 times 4, sorry, 7 times 6 times 5 times 4 times 3 times 2 times 1, all right? And so 2 factorial is 2 times 1, right? So what we can do here is we can clean this up a little bit, and let's say we call it 2 factorial multiplied by 5 factorial, right? Because that's going to be 7 minus 2. Now, what I can do to this numerator, this 7 factorial, is I can change it to being 7 times 6 times by 5 factorial, okay? Because 5 factorial is just going to be 5 times 4 times 3 times 2 times 1, so that's the equivalent of 7 factorial. Then I can divide this now by the same thing, 2 factorial multiplied by 5 factorial, and now I have an opportunity to cancel out my 5 factorials, okay? And so yeah, that makes our life a little bit easier, and so now we've got 7 times 6 divided by 2 factorial. We already know that 2 factorial is just going to be 2, because that's just 2 times 1. So we get this is equal to 42 over 2. And then we can sort of finish out by saying, therefore, B is equal to 21. And that is the answer to part A. On to part B. The third term in the expansion is the mean of the second term and the fourth term in the expansion. So I'm going to use a green highlighter for this question, okay? So the third term in the expansion, the mean, right, of the second term and the fourth term. Okay, so if we go through this and sort of have a think of what we got. So the third term is what we've just found, bx to the power of 5, and we're told that b is 21. So we can say, so this is 21x to the power of 5. The second term is ax to the power of 6, and we don't know the value of a yet. So we're probably going to, we're going to have to find that out. And the fourth term is 35x to the power of 4. Okay, so our first port of call will be to find out what ax to the power, or what the value of a is, okay? And the way we're going to do that is a very similar process as the part A in terms of finding the r value that we need in order to have x to the power of 5. But in this case, we need to find the r value that's going to give us x to the power of 6, okay? And so if we look back up at this bit here, all right, let's actually use a bit of a highlighter. If we look at this bit here, we can think, what value of r do we need in order to get x to the power of 6? And so specifically, that would be looking at the 7 minus r bit, and that's going to be 1, okay? We need r to equal 1, because then we're going to get 7 minus 1, which will then give us x to the power of 6. So let's have a look at that. So let's bring this down here, and we'll say ax to the power of 6 is going to equal 7c1 multiplied by x to the power of, 7 minus 1, but let's put in 6, and then multiplied by 1 to the power of 1, which is always just going to be 1, all right? And so off to the right here, we can say, therefore, a is equal to 7c1. Now, you can go through the formula here, all right, and lob this in, where we're going to get, 7 factorial divided by 1 factorial multiplied by n minus r factorial, which is going to be 6 factorial. In fact, we'll put this in. But a bit of a hard and fast rule that you can sort of remember is any number C1 is going to be that number, okay? So, for instance, here we're going to get, actually, let's write it in. So 7 factorial over 1 factorial multiplied by 7 times, 7 minus 1 factorial, which we should put in 6 factorial. Okay, and then using a similar idea as before, we could say that this is 7 times by, in fact, let's bring it down to a new line. Yeah, we'll bring all of this down to a new line. Let's bring this down, done. Okay, and so then this is going to be the same as doing 7 times 6 factorial. We know 1's just going to be 1 factorial is just 1 times itself, or just, it's just 1, so that's 1. And so we can say divided by 6 factorial, we can do our cancelling, and then we get left with just 7, okay? So therefore, a is equal to 7, so that's our happy days. All right, so now we know that we've got the second term is 7x to the power of 6, fourth term is 35x to the power of 4, and third term is what we've well, we were actually told what B was. So even if you couldn't answer, you couldn't sort of do the full answer for part A, you can still then at least attempt part B, which is quite nice. All right. So our second term, so this one here, so 7x to the power of, oh, sorry, beg your pardon. No, our third term is the mean of the second and fourth term. So 21x to the power of 5 is equal to 7x to the power of 6 plus 35x to the power of 4 divided by 2. Okay, so that's the way to calculate the mean of two numbers or two terms, or yeah, you add them together and then you divide by the number of terms that you have, which we have 2 here, so we divide by 2. All right, and cool. And so here we have an expression where we're going to have to do some manipulation, sort of figure out what we'll do from here. So first things first, what I think is a good protocol is just times both sides by 2, and so that's going to give me 42 x to the power of 5 here is going to give me 7x to the power of 6. I'm going to end up going on to the next page here, but that shouldn't be a worry. Okay, so here we have a couple terms. So what we could also do now is divide both sides, we could divide all sides or everything here by x to the power of 4, which would leave me with 42x multiplied by 7x squared plus 35. Okay, and then now if we bring everything over to one side, and actually what we'll do is bring this over to the left a bit, make it a bit smaller. Yeah. Make this a bit smaller, and then we can hopefully work off to the right. Yeah, that'll do. All right, cool. And so it's just putting a line down here. Well, we can bring all this to one side, yeah? And we can get 7x squared minus 42x. So I am subtracting 42x from both sides here. If I subtract 42x from this side, it's going to equal 0. And we get plus 35. And then this is equal to 0. All right. And so now I have a quadratic for which I could just lob into the quadratic formula. So we can simplify it and then attempt to factorize. Now, I don't recommend spending too much time in trying to factorize something, because sometimes it can't be done. But yeah, always sort of briefly think to yourself, can I factorize this? Because it is more efficient than sort of plugging it into the quadratic formula. All right, and so from here we get to the idea of we divide all of our terms here by 7. We'll get x squared, and we're also, so we're dividing the whole equation, so the left-hand side and the right-hand side by 7. And if we divide 0 by 7, we just get left with 0, okay? So 7x squared divided by 7 is x squared minus 6x, and then plus 5 is equal to 0, right? And so then from here, what we can do is attempt to factorize. And so because we have a positive c value, all right? Or actually, first things first, what we're going to look at is the coefficient of x squared. 9 times out of 10, that is going to be just 1, right? Which is quite nice. So then we can sort of start our factorization with just x and x, okay? And so now we look at our c term, right? Our c term is positive, which means the sign within our brackets, they're going to have to be the same, all right? If it was negative, then that means they're going to have to be different, right? And so now I say the same, that means they can be plus and plus or minus minus. And you may ask how do you figure that out, or where do you go to from here? And the place we go to is the b term, okay? And we see that that's negative, right? So we're going to need minus minus, all right? And we think now, what are factors of 5 that add up to 6, all right? And it's quite fortunate 5 is a prime number. It only has 5 in itself, so 1 in itself, and that 1 plus 5 is 6. That's quite fortunate. So we get x minus 5 and x minus 1 is equal to 0. Okay, and so therefore the possible values of x are x is equal to 5 and x is equal to 1. Right, and then there is the answer to part B. And question 6.